Let me just get this out of the way. All right, guys, welcome back. How do you hide this? Hide, 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 hide. All right, here you go. All right, guys, welcome back. So today, guys, we're actually going to look at formula writing again, but this time with transition metals in polyatomic ions. All right. So let's take an example first. So remember, guys, how do you write down the formulas for ionic compounds? Remember, it follows these four steps. Okay. So first of all, we need to write down the symbol with the correct charge. Okay, the middle on the left, the non-middle on the right. The second step, we cancel the positive and negative signs of the charge. Remember, we have to crisscross. Okay, the numbers of the charge so they become subscripts, and then lastly, we report the numbers in the simplest terms if possible. All right, so let's take an example. So let's take a really quick example on how to do this. All right, let's look at a blank page for example right here. So give me a second. All right, so let's talk about, for example, when we're looking at calcium chloride. So again, let's look at the example calcium chloride. Okay. All right. So again, guys, how do you write down the formula based on the name? All right. The first thing you need to look for is the element symbol and its charge. So let's start looking through our periodic table. All right. So you go look at the periodic table. Okay. Hopefully, in your notes, you find where uh, calcium is. All right. And you're going to find out this is Ca. And then again, what's the charge for calcium? You're going to see it's plus 2. Okay. Or 2 plus. It's up to you how you want to write that down. That's fine. Okay. Now let's look at the periodic table for chloride. All right. Okay. If you look for a chloride on the periodic table, you're never going to find it. Okay. Because remember, guys, when we combine ions to form the ionic name, okay, the ionic compound name, we always change the last part to IDE, okay? So to look for this element, you can ignore the IDE part and just look for the element that starts with the first syllable, chlor. If you look through the periodic table, you're going to see that this is chlorine, okay? All right. So if you look for a chlorine in the periodic table, you're going to find the symbol is Cl and the charge is -1 or 1 negative. It's up to you how you want to write this. Again, guys, 1 is invisible, but for the sake of just looking at the numbers right now, we're going to write down the 1, but don't forget, in the final answer, 1 is always invisible, right? So what you're going to do, okay, it says there, we write down the symbol with the correct charge, so this is it. Step 2 is we have to erase, cancel out the positive and the negative. So Ca plus 2 simply becomes Ca2, okay? And Cl minus 1 simply becomes Cl1, all right? So what's the third step? We switch the numbers, we crisscross. So the 1 actually goes to the Ca, the 2 actually goes to the Cl. And what you get is Ca, Cl2, all right? Ca1, don't forget there's a 1 there, okay? But remember, one's invisible, so I forgot to write it down. But for now, let's just look at the 1. Okay, so it's Ca1, Cl2. All right, in the last step, we want to report these numbers in the lowest terms possible. So think about it. What will be the number? What will be the lowest terms number? What number can we divide 1 and 2 and get a lower set of numbers that are whole numbers? Well, you can't think of anything else except 1, right? So if you divide 1 and 2 by 1, you get exactly the same answer. So that's it. That's the answer. You just need to remember that 1 is invisible. So this is now CaCl2. And that's the formula, right? Okay. All right. Let's talk about, let's take, for example, barium sulfide. Okay. Barium, okay, sulfide. All right. Let's take another example just really quickly. Let's take another example. Okay. Right. So look for barium on the periodic table. If you look at barium, Ba, right? And the charge is plus 2. Right. Again, sulfide, you're never going to find that because, again, of the IDE. Remember, we changed that. So you look for sulf, the element that starts with SULF, and you're going to find this is sulfur. and sulfur is S negative 2. Charge is negative 2. Right. So we got the identities down. Don't forget, you take out the positive, we take out the negative, and we switch the numbers. Okay. This becomes Ba followed by a 2, S followed by a 2. Right. Now look, are we done? Not yet. Remember, we want to report these numbers in the lowest possible terms. Okay. So think of a number to divide 2 and 2 to get a lower set of numbers. And the answer would be you divide them by 2. So the final answer would be BA 2 divided by 2 is a 1, but 1 is invisible. S 2 divided by 2 is a 1, again it's invisible, so the final answer is BAS. All right? So that was the lesson from last time. But wait a minute. Hey, Mr. Chua, where are you getting those charges? Again, guys, to get the charges, you just think about whether it gains or loses electrons. Okay? So, for example, calcium has two valence electrons, right? So, Ca has two valence electrons. Okay? So, you can think about it that way. So, give me a second. This thing is going crazy on me right now. All right. So, for example, Ca, if you look closely at the periodic table, it belongs in group 2. So, therefore, it has two valence electrons. And you go ask yourself, remember, we want eights. Remember, the goal for all elements is to have 8 valence electrons or nothing. So, look at it. 2. So, which one is easier for calcium, which has 2 valence electrons? Gain 6 more, okay, to get to 8 or lose the 2. Since 2, lower 2, the lose 2 is the lower number, that's going to be the possible charge for calcium. So the possible charge for calcium is Ca plus 2. All right? Give me a second, guys. Go ahead. Thank you. Yeah, no problem. All right, you too. So, hey, so what we're looking at here is Ca plus 2. All right? Ca plus 2. All right. Perfect. Now, Mr. Chua, is there an easier way for us to know the oxidation numbers or the charges? Yes, remember I gave you notes on that. If you look at your lesson 16, okay, if you look at lesson 16, your notes for lesson 16, okay, I gave you that list, okay, it should be in this periodic table right here. You see it? At the bottom, it gives you the charges or oxidation numbers, okay, and at the top, it shows you your number of valence electrons right there. Y'all see it? All right, cool. All right. Hey guys, if you notice, look at this periodic table right here. We got the charge for the first group, the second group, okay, the third, fourth, fifth, sixth, seventh in group 8 or group 18. But we don't have any charges for the transition metals. All right. Why don't we have oxidation numbers for transition metals? Remember, guys, we said transition metals have a C of electrons. Okay, C of electrons, which means the electrons are moving around so much that we don't really know exactly what is the charge. Okay, there's like so many of them because they keep on moving around. There are so many possible charges. All right, but even though that is the case, we still have only what you call stable oxidation numbers. All right. So we only have stable oxidation numbers. So in this lesson, guys, I'm actually going to give you a list. I'm going to give you a list of ions. So if you look at lesson 17, uh, all right, if you look at your notes in lesson 17, okay, and let me get my notes for a second. Let me get them up. Lesson 17. And I am lost. Give me a second, guys. I'm sorry. It's here somewhere. It's here somewhere. Note sheets. And then we're going to go to formula writing. All right. Here we go. So, guys, if you look at your note sheets today, all right, I gave you a list. It's right here. Okay. So if you look at your note sheets, guys, today, I actually gave you a list. of those, only a few, actually not all of them, but I gave you a list of transition elements and their possible charges. All right, you see it here. Okay, see it? All right. So these are transition metals and their possible charges. All right. So let's try to use, okay, these and try to figure out the formula. For example, guys, if I gave you, let's say, iron 3 chloride. So let's take, for example, I want to figure out the formula for iron 3, okay, chloride. Okay, what will be the formula for this? All right. If you look closely at this one right here, okay, if you look at your periodic table, you're going to find out that iron, Fe, is a transition metal. All right. The question now is, what's the charge? All right. So if you look at the list, okay, the list right here, you're going to see that iron 3, the charge is positive 3. You see it? Okay. All right. So what if you lose this list? What if you don't have it on the test? How can you determine, based on the name, the charge of the transition element? Guys, the key here is the Roman numeral inside the parentheses. You see it? So again, you see that Roman numeral right there? It tells you the charge. So Fe here is positive 3. See it? Right. Let's talk about chloride. Again, same as always, you're not going to find this in the periodic table because we changed the last part to IDE. So we have to look for chlor. So I look for chlor in the periodic table and I see chlorine, okay, chlorine, and it's Cl negative 1. Actually, again, it's negative 1, but again, for now, we'll show the 1, right? But remember, 1 is invisible. You don't have to show the 1. All right, so what do we do now? Since we have the symbols and the charges, we can now do what we do best. Remove the positive and the negative, and then you switch the numbers, okay? And what you got here now is Fe1 Cl3. All right. Now look, again, you have to look at those numbers that you just wrote down, 1 and 3. Okay. Think of a number to divide 1 and 3 with and get a lower set of numbers. If you think about it, there is no number, okay, that you can divide 1 and 3 and get a lower set of whole numbers. All right. So what do you do? That's it. That's the answer. So the final answer here is FeCl3. And that is the correct answer right there. All right. So don't forget, 1 is invisible. All right. Okay. All right. Let's try another one. Let's take, for example, guys, you were looking at lead 4 oxide. Lead 4 oxide. Okay. So if you look at your periodic table, lead is Pb. And the charge of Pb here, if you look at the parentheses, it's positive 4. IV means 4 in Roman numerals, right? Oxide. Guys, you're not going to find oxide again on the periodic table because of the IDE. So look for one that starts with OX, ox, and this will be oxygen. Okay? And this is O, negative 2. See it? All right. Now, same as always, we take out the positive, we take out the negative, and you cross the numbers. Okay? And you get PB2O4. All right. But look, okay, think of a number that you want to divide 2 and 4 with and get a lower set. Think about it. All right. Are you thinking about the same number? So it has to be 2. Okay. So I divide that. So PB2 divided by 2 is 1. 1 is invisible. O, 4 divided by 2 is 2. And therefore, that's the final answer right there. You see it now? Cool. All right. Okay. Now, remember, guys, this. Okay. Now, what happens is this. All right. Right. What happens, guys, if the formula, all right, and let me show you this. Let's go back to this one right here because it has more space. No, not really. Let's go back here. All right. Okay. So what happens now? What if, for example, you're trying to figure out the name of the compound and the name of the compound? Let me just copy this somewhere. so that we can have more space. Uh, More space. And remember, guys, this you should have this note sheets. Okay, and don't forget to complete the notes. Control V, and then all right. So for example, now, all right. Let's continue. So, guys, for example, all right, and this is what if the compound that they asked you to write the formula is sodium? Okay, sodium carbonate. Let's make this bigger, smaller. Okay, sodium carbonate. Let's make it bigger. Nope, smaller. Nope, same size. Okay, how about sideways? Give me a second, guys. Let's put some more space here. Let's make it landscape. All right, there you go. That should fit. All right, so like I was saying, guys, what if the formula that you're looking for, okay, is the formula for sodium carbonate? Okay, that's a good. This one's a good one. All right. So we always do exactly that we've been always doing. Sodium, you look for it in the periodic table. You're gonna find it's Na, and the charge is positive one. All right. But look at carbonate. Okay, you won't find this in the periodic table. If you say this is carbon C, no, that's wrong. Okay. All right. This is actually not in the periodic table. This is what you call a polyatomic ion, and it's going to be coming from this list. You always have to look through this list for polyatomic ions. Again, this is called polyatomic ions. What does polyatomic ions mean? Polyatomic ions mean that the ion has more than one type of element, which means it's going to have more than one capital letter in there. Okay? All right. So if you look closely at this list, you're going to see that carbonate is right here. Okay. See it? So the formula for carbonate is big C, capital O. So there's carbon and oxygen, a 3, and the charge is -2. See it? All right. And then you just follow exactly the same pattern that we've been doing. Okay, you actually follow the exact same pattern that we have been doing. All right. So look closely. You take out the positive, you take out the negative, and then you cross those numbers. Okay. All right. So before we do that, I want you to look closely first at CO3, -2. You see that 3 there? Okay. All right. If you look at that 3 is already a subscript. It's already down there, which means you don't change it. You never ever change a number that is already a subscript, okay, when you get the formula ion. I mean the ions. You got it? So again, since it's already down there, you never ever change it. So look. So Na followed by a 2, right? And then you go CO3, okay, followed by a 1. But 1 is invisible. You got it? 1 is invisible. Okay, so, okay, let's put that 1 just for clarity's sake, all right? We're going to put that 1. So 2 is the one that you switched from CO3, and then you got a 1 here. Okay, again, guys, the 3 you don't touch, all right? So again, you never touch the 3 because it's already down there. See it? Okay, so think about a number that you can divide 2 and 1 with and get a lower set of numbers. Remember, we're still following the 4-step procedure. Okay, you can't, right? So that's the final answer. It's Na2CO3 followed by a 1, but since 1 is invisible, we don't write it, and that's the answer right there. You see it? Okay, right. Now, what if we got two numbers? Oh, wait, before we do that. Okay, all right. So, first of all, again, carbonate. You will not find this in the periodic table. So, you have to look at the polyatomic ion list. All right. So, the question in your mind is this: when should I look in that list? All right. That's a good question. Guys, if the ion, okay, if the ion ends in IDE, you look for it in the periodic table. Okay. For example, chloride. So you have to look for the symbol for that in the periodic table. All right. But if the ion ends in either ITE or ATE, you use the list. Use the polyatomic ion list. Look at the polyatomic ion list. Okay, and which list is that? It's this list again. Okay, so again, one more time. If the formula, if the ion ends in IDE, if the I mean the name of the ion ends in IDE, you have to look through the periodic table. If it ends in ITE and ATE, you look in the list. All right. Of course, there's an exemption to the rule. Which are exempted in this rule? Well, there's two of them. Okay, let me erase this. Okay, who are exempted from this rule? Well, there's two of them. It's cyanide. Okay, you see it? It ends in IDE, but it's in this list. Okay, and the other one is peroxide. It also ends in IDE, but it's on the list. So those are the only two exemptions to the rule. You got it? All right. So look, let's try it again. What if this time, guys, I want to find the formula for a calcium phosphate? All right. So again, same as always, look for calcium, and you're going to see calcium is Ca plus 2. I'm going to move it to the right a bit, okay? All right, phosphate. Okay, look, it ends in ATE. Where am I going to look? In the periodic table or on the list? Think about it. Okay. Since it ends in ATE, I'm going to look in this list. Again, you look in this list if it ends in ITE or ATE. Okay, you got it? So where is phosphate right here? Phosphate is right there. Okay, and let's write it down. So it's P, big P, capital P for phosphorus, oxygen, 4, -3. Okay, right. One more time. Guys, you see that 4? Again, if the number is already a subscript, you do not change the number. You don't do anything to it. It stays exactly where it is. You got it? All right. So guys, we're following the steps again. We wrote down the symbols with the charge. Now we want to erase the positive, erase the negative, and switch the numbers. Okay, so we're gonna switch. So we get Ca3, right? Then big P, big O, 4, followed by a 3. All right. So in the last step again, guys. Oh, I mean two. Sorry, 2. Okay. All right. Remember, guys, in the last step, you have to report the numbers that you switched. Okay. Only the numbers that you switched in lowest terms. So the numbers that I switched are 3 and 2. So look at 3 and 2. Can you think of a number to divide 3 and 2 with and get a lower set of numbers? No, right? So there's no other number that you can divide 3 and 2 with and get a lower set of numbers. So the answer is this. But if you look closely, guys, excuse me, if you look closely, the answer looks like Ca3PO42, right? So how can we make sure that we know that the PO and the 4, okay, is actually separate from that 2? That the 2 actually tells you that there are 2 PO4s. Okay, we have to use a parentheses. All right. All right, so let's put a parentheses. All right. So do we put a parentheses around the 2? Okay, no, don't forget, that's wrong. Do we put a parentheses around the 4? No, it's wrong. What you do is, to separate them, you have to put a parentheses around the polyatomic ion, the one from the list. You got it? So that's how you use the parentheses. Okay, use the parentheses around the polyatomic ion if the number that you're going to cross behind it is bigger than 1. Okay, Remember, we never used the parentheses earlier because the number that we crossed was 1, and this is 2. So therefore, we have to use a parentheses. You got it? Okay, let's try it out again. So that's the answer for that one. What if it's aluminum? Okay, aluminum phosphate. Okay, all right. So again, same as always, step 1, find the symbol and the appropriate charges. So again, aluminum is Al and it's plus 3. Okay, all right. Phosphate ends in ATE. So where do I look? In the list, this list. And phosphate is right there. So again, it's PO4 minus 3. All right. Someone asked earlier, hey, Mr. Chua, if we have the same number in the charge, can we cancel them out already? Yes, you can. And that is a very good idea right there. So since they're both 3 and 3, they can cancel out. Okay. That means you're left with 1 and 1. Okay. That's what you're switching now, 1 and 1. So take out the positive. Okay. So don't forget to erase the positive because you don't want to cross that. And the negative, and you cross it now. So remember, we don't have the 3, we just have a 1 and a 1. So AL1. But remember, guys, 1 is invisible, right? And then you got PO4 followed by a 1. Guys, you might think we need a parentheses, but we don't because 1 is invisible, so we don't need a parentheses. So this is already the answer. Okay, and again, look close here, right? The 4 stays there. You got it? Because again, it's already been there. You don't touch it. Okay, I'll give you a good example of why, for example, and this is a common mistake by a lot of people, that they touch that subscript even though it's already there. Okay, I'll give you an example. For example, guys, and this is very common, this is called hydrogen peroxide. Okay, and you know this, hydrogen peroxide. You buy this from Walmart, you want to go blonde, you put in your head, there you go, blonde, hydrogen peroxide. So how do you write down the formula for hydrogen peroxide? Okay, look, hydrogen is H. You're going to see that the charge is positive 1. Okay. Peroxide. Remember, this is one of those exemptions to the rule. Even though it ends in IDE, it's on the list. It's right there. And peroxide is O2 negative 2. All right. Y'all watch closely, right? Because it's super important. You see that 2, right? And what did I say? If it's already a subscript, you leave it alone. You leave the 2 alone and never ever change it. Okay. And a lot of people make this mistake. Look, so what do we do again after we get the symbols? We take out the positive, we take out the negative, and we cross the numbers. Okay, now look. So this should have been written as H2, right? O2, which was already there. So let me change it to blue. Remember that 2 was already there. And then followed by a 1. But remember, the one that you switch, 1 is invisible. So this is what it looks like. Okay. And this is already the correct answer. Okay. The problem is this. Kids would go like, oh, wait a minute. Those are both 2's. So I can actually divide that by a 2, divided by a 2. And then the answer would be H2 divided by 2 is 1. So 1 is invisible. O2 divided by 2 is 1. So it's just going to be HO. All right. This is wrong. Okay. The answer is not HO. Why? Remember, I told you guys that the 2 that was down there that you put, remember, in that 2 right there, that was already a subscript to begin with. I told you before, never ever touch it and never ever change it. Okay. If you divide it by 2, it turns into a 1. You changed it. So you should not do that. So the answer here is not HO. Okay. The answer is not HO. The answer is already H2O2 because again, that 2 is already been there and you do not touch it. All right. You don't touch it. And remember, hydrogen peroxide, the formula is indeed H2O2. You got it? All right. Hey, I want you to practice with all of the other examples given in the paper. Again, guys, if you have any problems, any sort, again, check out the lessons that we have and check out the videos there. And when you come back here, we'll focus more on this one right here. All right, take it easy.